Hi, welcome to another episode of Yummy Data Science. In this episode, we are going to continue talking about healthcare claims data and related analytics. Specifically, we are going to be focusing on inpatient or facility claims data. We are going to make a data model for optimal cohort analysis. And I'll be showing you all this using Python Pandas. So, and I'm going to assume that you have no familiarity with Python Pandas, but have some technical tools under your belt, such as, say, SQL, or maybe R, or maybe a bit of SAS. And I'm going to be going pretty fast. And the reason I'm going to be doing that is I'm going to be programming in Python Pandas with the assistance of AI. And I'm going to show you how to do the thinking work yourself, the analytical planning work yourself, and writing a series of prompts that then translates into Python code, which you can then tweak and learn to improve your understanding and to improve your program. So several things are going on in this video. We're going to be talking about inpatient claims. We're going to be talking about how to create a data model. So that's another concept and objective. And the data model will be created with a view for cohort analysis. And plus, we're going to learn Python Pandas, but we're going to learn it assisted with AI. So let's get going. Key concepts of inpatient claims data, also known as facility claims. Facility because this is brick and mortar. These are buildings. These are claims, invoices for healthcare services rendered in buildings. The concepts are explained in a prior video, which I've linked to, and it's called Key Elements of Facility Claims. And in other prior videos using RStudio and Tidy Suite, we have talked a little bit about exploratory data analysis and also data modeling. But now we're going to be doing all that in Python Pandas and assisted with AI. So where are we going with this? We are going to take our claims data and we are going to organize it into two separate files. And it's a mini data model. And a data model, if that word is new to you, it simply means it's a blueprint or a map for organizing data. And what I've got here is a patient year. So Bene ID is patient ID. So Bene ID, year, and I've got their diagnosis. So that's like a driver file. Now, given a diagnosis, say diabetes, say we are interested in a study on diabetes, patients with diabetes, you can then go to your diagnosis file, pick out your cohort, and then join with the relevant inpatient encounters. And this symbol, if you peer closely enough, you'll see there's a 0 plus sign here. And that simply means that the joined relationship between these two files is 0 to many. So one record in diagnosis could join to 0 records. So that person could have no inpatient encounters, or they could have one, or they could have many. So that's what the data model, quick refresher on data modeling. And for a quick recap of where this data comes from, here is the link. And if you were to type that in Google, you'd be able to, it would take you to the CMS website where the data is. And we are focused on the Medicare fee-for-service claims. Medicare is administered in two separate ways. And we are focusing on the fee-for-service claims. And we are going to be talking about the inpatient claims in this. So now let's hop over to Google Colab, where I will be going through the inpatient claims notebook, and not only teaching you Python Pandas, but also teaching you how to code using the available AI assistant. I chose Google Colab among a plethora of other tools resources simply because it is free and it is really easy to get started with. Um, and so you'll see here that in my Google Drive, I made separate folders for the data. I downloaded the data from CMS and I put it in a folder. And anytime where you see prompt, that's what I typed in. And I said, prompt load my Google Drive. So instantly it gave me this piece of code. Um, Obviously, Pandas, NumPy, and DateTime, these libraries are not part of this prompt. They were taken from a later prompt when I was reading the files. I just copied it so it would all be organized. So in your top shelf, on your topmost cell, you want to have your libraries and you want to mount your drive. So create your data connections. And this says, for the sake of speed, I have pre-run this notebook. So it's been mounted. And I'm going to be reading in the inpatient file. So I'm telling it exactly where it is. Then I'm also reading in some lookup files. One is for DRG, which is diagnostic related grouper. And it's a way of categorizing inpatient stays with respect to diagnosis and utilization and several other things. And the DRG system was first created by Yale University. So I'm reading in those DRG and their descriptions. I'm also got a lot of ICD-10 columns in my inpatient data. These are diagnosis columns. I've got more than 25 of them, 26 of them. And so I want a lookup. And usually in your data warehouse, the lookups may be stored in another, but for the sake of our small data model, I'm going to attach the descriptions to the files themselves. Okay, so that's where the file paths are. And here what I'm saying is I've got two ICD file paths, and this is simply because, and this is a good caveat, so I want to explain the shortcut I took. ICD codes and their descriptions are given by year. I downloaded the one for 2025. And so my data, the Medicare synthetic data, covers from 2015 to 2023. So there were a few diagnosis codes whose descriptions were not in my file. So what I should have done if I were to do this the hard and the correct way is I would have downloaded the ICD descriptor files for each of the years between 2015 to now. And then I would have concatenated that. But instead, what I did is took 2025 descriptor, and what was left, I asked Perplexity AI to look it up. Then I looked up a few of them and I went with that. So this was a shortcut, but I would not recommend doing it for a formal project. And then in this cell, I am reading my DRG and the ICD, the two files, which I'm going to concatenate later on, that I'm going to stack later on. Concatenate is a Pandas term for stacking data sets. Stacking is to put one on top of each other. So here I'm looking at DRG and I'm looking at some information from it. And you've already guessed it, the way that Python Pandas works is you chain different methods and functions to it. So here we are taking an LUDRG, that's a data frame. Dot means now we're going to chain something to it, either a function or a method. And we are calling the info method. And the info method is going to tell you how many rows and what are the types. So this is telling me that DRG was read in as a int 64 And I don't want that. This should be read as a character. So one of the first things I'm going to do in the next um, uh, cell is to fix that. So in the next cell, I am renaming description to DRG description. And look at the way that this is very nicely laid out. So you have the name of the data frame dot, then you're using the rename method, and the rename method can take in a dictionary. So anything that is in the curly braces, that's called a dictionary. And so with the dictionary, there's a key value pair. So here's the key, here's the value. And what this is saying is, here's the existing name of the variable, and now you want to change it into DRG description. So if I were renaming multiple variables, I could keep adding it inside the dictionary separated by commas. And then this is the rename method that I'm using. And as you can see, it's giving me a lot of good good syntax help. And in place simply means overwrite this data set. Okay. The second line, and I promise I'm going to pick up speed. So the second line is saying, recall that DRG was read in as an int64. I do not want to do that. In fact, I want to read it as a character, and anything I want to pad it. So if it's less than 3 digits, I want to pad it. So that's the zfill function. I want to pad it with the zeros. So let's start reading it. So take LUDRG, then take the column DRG in here in the square parentheses. First, you fill any of the blanks with a 0. And this is important for the zfill to work. Then read it as an integer. And then read it as a string. And then use the zfill method, which is not pandas. That's base Python. And so in order to use the zfill method, which is not pandas, we had to use the accessory str. Okay. And you can also copy this and ask, say, Perplexity AI to explain it to you, and it will do a very good job. So now I'm renaming some of the other columns, and now I've put my ICD finals, I've concatenated it together. And you can see the concatenate method of pandas takes in a list of data frames in the square brackets. So I could put as many as I need here. Okay, moving on. Now we are reading the inpatient file using the read CSV method with the separator as tab. And now I want to know how many, what were the columns in inpatient and what was their type. So call inpatient is a data frame of exactly that. And now I'm looking at call inpatient. So you'll see here that this is a new functionality in Colab. You can actually interact with your data frame by pressing this. And now I can sort it any way I like. I can filter. So if I look at this, I can see that the data frame has a lot of columns that are numbered 1 through some number. And if you have watched the videos that are linked to before, you know that this is the present on admission indication flag. Was the diagnosis present on admission? Yes, no. E is for injury codes. I'm not interested, so I'll end up dropping all those. But what I am interested in is the ICD codes. So here are more present on admission, and these are the diagnosis codes. Again, I'm not interested in these flags. The columns that I'm interested in are ICD diagnosis code 1, and there should be a principal diagnosis code. So see, there are almost 200 columns, so there's a second page here. And here is the procedure date, because recall that the facility claim also has surgical procedure codes, which I'm not interested in. So I'm going to be dropping those as well. See these ICD procedure codes and the procedure dates. And anything that ends with UPIN, that is outdated. So I'm going to drop everything that ends with UPIN. Okay, so we used this data frame, which had columns and the types to look at our data set. Now we are going to reformat some of the columns we read, because that's important for our analysis. For example, PenAID should not be read in as a number. It is a character. It has no meaning whatsoever as a number. What does it even mean to take an average of the patient ID? So those are some of the kinds of transformations I'm doing in my cell 7. I'm converting columns to appropriate data type. So BenAID, I am as type string, and so on. And I'm doing that. Now for the date columns, I'm using the PD to date time method, and I'm giving it the format. Now I do want to talk about this line here, where I'm computing length of stay, so loss. So length of stay is the difference in days between claim through, which can be taken as a proxy for the date of discharge, minus the claim from, or a good proxy for the date of admission. And what's going on here is, you can see the arithmetic is pretty simple, but then there's a dot dt. And dot dt is simply an accessory. It's an accessory, and it accesses, it's saying, okay, we're calling for a time delta. Because in parentheses, we have two date fields, so it's going to be time delta. But what's the time delta in? The time delta is in days. So that's what it's doing. And it's adding a day because it's conventional not to have a length of stay of 0. If it's same day discharge, it's going to have a length of stay of 1. And here I am creating a column called year. And I'm taking the claim through patient date. And using my DT accessory, I am getting the year out of this date. So here we've already talked about the DRG manipulations in which we do Z-fill, so I'm not going to go over that. Now this, when we dropped columns, you can see how Pandas is very handy, because you can build column list. So we want to drop column DRG code, and we want to drop all the columns if POA is in the column, or if the column ends with UPIN, or if it starts with this, or it starts with procedure. And in the next line, we have dropped those columns. And if this is going too fast, please look at the exploratory inpatient claims analysis videos. There are 3 of them, and they explain step by step why this data is being transformed the way it is. So since I'm not, inpatient claims data is composed of 2 sections. There is a header section to any claim, and there's a detail section. So I'm not interested in those detail lines, which are denoted by claim line num. And I'm only interested in the first line, because that will give me the header. The header is repeated for every line, for every value of claim line. So I'm filtering the rows because I'm only interested in the claim header. And then I'm creating an ER flag. And for facility data, So facility is hospital, and hospital has various departments. So the ER, the lab, so forth. So the way you figure out if a claim is an ER, has an ER visit to it, is by looking at the revenue center. What was the department? And if the department is 450, and this is something I know a priori by looking it up, it's 450, and the length of stay is 1, then let's call it an ER. That's what it's saying. And in a former video, I explained my reasoning for creating this criteria, adding in the length of stay is equal to 1 to this criteria to create their ER flag. So, okay, we have done all these manipulations, and now we can take a quick look. So, what are the columns I'm interested in looking at? Well, it's the Bene ID, year, all my diagnosis columns, and I want to look at the first 5 records. Because where I'm going with this file is I want to create a diagnosis level file, beneficiary, year, and their diagnosis. And it's going to be in a long format. So each row is going to tell me about a beneficiary's diagnosis for a certain year. So you can see that the first beneficiary and the year is 2015, and he has, he or she or they have a plethora of codes here. And it doesn't show me all of these. So there's a dot, 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 and there are some nans. These means that they were not populated. So now we are gearing up to make this wide file into a long file. And for that, we are going to use the Pandas melt method. So first we subset diagnosis for the columns of interest. And then we use the melt functionality. And ID var simply means what variables do I want to keep the same. Var name means once I have made my data set from wide to long, what is going to be the name of my variable, where the column names, the previous column names are kept, and the value name is the ICD diag code that's going to have these diagnosis codes like Z3480. And in truth be told, I'm not interested in whether it was coming from the first diagnosis or the 23rd diagnosis, so I'm going to be dropping those. Next, I'm going to remove where, we have all these nans. They will be creating duplicate several rows. So I'm going to get rid of where it's not, it's not missing. Where it is missing. And then I'm going to be dropping this ICD diag call because I don't care where it came from. And now I'm removing the duplicates. You can see that there are duplicates here. If you look at row 2, that the principal diagnosis and the first diagnosis columns are the same. So that removes the duplicates. So then here, this is very good practice. As you're going along with transformation, you're checking. And so I checked, I did a micro level check. I looked at this Bene ID, and then I eyeballed that this is the correct transformation. Now I'm going to take my diagnosis file, merge it with my ICD lookup so that I can get their diagnosis description. In the next cell, I can take the diagnosis file and I can group it by Bene ID and year. And what that will give me is I would like to count how many diagnoses did the person have by year. And it could be a proxy for comorbidities. And I'm saying proxy because that is generally not how comorbidities are counted. So when we do group by, it breaks up the data set into little pieces that are grouped by distinct values of Bene ID and year. And then having made these little groups, we are invoking the size method, and the size will tell me how many rows are uh, in this little group. And then the group by, what it does is it pushes your grouped columns into the index. The index, if you recall, in Python goes from 0 all the way. So it pushes Bene ID and year, their values, into the index. So we want to undo that functionality. And it does it because that's what's important for it to group the values. So we do reset index. And then this, since we had explicitly called out that we were interested in size, if we put name here equal to numDiag, then the size column, which would be given a default name, is now named numDiag. So now we have a number of diagnoses. We have the diagnosis table. We have the inpatient encounters. I just cleaned it up a little bit. And the inpatient encounters, I merged on num diagnosis. So with the encounter file, I also have how many comorbidities did this person have. And then I also attached the diagnosis code descriptor. So what we are going to end up with is the inpatient encounters file, which is like this. Each row is an encounter, and it tells me what the length of stay is. It tells me what the DRG is. It tells me what the DRG description is. It tells me what the principal diagnosis code is. And it tells me what the diagnosis code description is. And we also know that there were 9 diagnoses that this person had for this year. So we have attached some useful information. And then finally, we have saved this, because once we do this with each setting, we have done this with inpatient, we'll do this with outpatient, we'll do this with pharmacy, we'll do this with professional claims, then we'll be able to build a holistic picture of the person's encounters and the person's diagnosis. And that will be our true data model. So thank you for listening. On to the next video.